example. This is actually from the book that you guys don't have, but that we are technically supposed to use. After filling the ketchup dispenser at the snack bar where she works, Kelly measures the level of ketchup during the day at different hourly intervals. Actually, they're each after 3 hours. Anyway, that's fine. So what we're going to do is we want to write an equation that represents how much ketchup is in the bottle depending on how long it's been. I have some minor issues with this problem. First of all, we have mustard and mayonnaise, but we aren't doing anything with them. But they're still in the picture. I don't know why. Don't worry about those. The other thing is it's measured in inches, which I understand. You could have a vertical thing and be like, oh, this is this many inches, but you don't measure ketchup in inches ever. It's in a volume, so you should have something cubed. You can have cubic inches. That would still be strange, but you could do that. Anyway, moving on. Okay, so we want an equation. We want an equation in slope-intercept form that represents how much ketchup is in the bottle based on how much time has passed. So ketchup in the bottle is y. Ketchup. My pen's acting weird. And time. Okay, and you could do this a whole bunch of different ways. You could draw a graph and figure it out that way. I'm actually going to make a little table. Whoa. Yep. A little perfect rectangular table. Something like this. Here's my time, and here's how much ketchup I have. And so here I have 5, 8, and 11. And for my y, I have 11 and 7/8 after 5 hours, and 10 after 8 hours, and 8 and an eighth after 11 hours. Okay, so first I'm going to find my change in x. That's 3 hours there, and that's 3 hours there, so that's good, that's constant. To get from 11 7/8 to 10, that's minus 1 and 7/8. To get from 10 to 8 and an eighth, that's also minus 1 and 7/8. Though that's not quite as apparent, but 1/8 plus 7/8 is a whole, so that'd make it 9, plus another one is 10. Okay, so remember our slope is our change. I'm going to use what we call a delta. Our change in y, I don't know why triangles are deltas, but that represents change. So our change in y over our change in x, and our change in y is negative 1 and 7/8. And our change in x is 3. So every 3 hours we lose negative 1 and 7/8 inches on the ketchup ruler or something. That's a pretty ugly fraction. Let's get it into a unit rate, so we're doing per hour. So m equals negative 1 and 7/8. Let's turn that into an improper fraction first. So 1 times 8 is 8, 8 plus 7 is 15, so that's negative 15/8 over 3. And then that would become negative 15 over 24, which would equal, both are divisible by 3, negative 5, sorry, 8s, negative 5/8. Okay, so our slope is negative 5/8. Y equals negative 5/8 x plus b. We still don't know what our b is, right? But we can plug some things in. And because I have an 8 here, I kind of want to cancel that out. So the easiest way to do that is I have an 8 right here. And I know that 8 divided by 8 is 1, and that'll just leave me with negative 5. So let's try plugging this in. So we're going to say that y, because if I'm using 8 for my x, then y is 10. So 10 equals negative 5/8 times 8 plus b. And if I do some simplification, 8 divided by 8, that just becomes a 1. So 10 equals negative 5 plus b. Add 5 to both sides. Sorry, that's a little messy. And 15, 10 plus 5 is 15. Negative 5 plus 5 goes away, equals b. So my final equation would be y equals negative 5/8 plus 15. Okay, with each of these videos, hopefully you're trying them before you're watching me do them and checking your work and making sure you get the same answer I got. Unless I got it wrong, which in this case I did not. I tested.